Okay, so let's scoot on. We're going to talk about the next section, more equations of lines. So in order to talk about this section, we are going to develop what's called the point-slope form. We've already spoken about slope-intercept form, and now we're going to move into a different form known as point-slope. Now, to get to that point-slope form, you have to remember the slope formula, and here it is. Okay? Now, here's the deal. I want to get rid of this denominator. So since this denominator is attached by division, what do I have to do to get rid of it? Good, I have to multiply, which means I need to multiply both sides by the denominator. Is that correct? Okay, so when I multiply both sides by the denominator, on the right side, what happens? Good, these will drop out. Agreed? And what remains is m times the quantity of x1 minus x2 equals y sub 1 minus y sub 2. Correct? Okay. I am going to turn this around and I'm going to put the y's on the left. Stick with me. Now, here's the deal. We're almost there. This form is called point slope, which means I'm going to input a point and a slope. Now, in our result so far, I have a y1 and y2 and an x1 and x2, which implies there's 2 points. I don't want 2 points, I want a single point because this word point is singular. There's no s at the end to say points. There's no s, which means it's singular. So I need a point and a slope. I already got the slope, m, so we're good. But I need to get rid of one of these points so that I just have one. So, the point-slope formula, or I should say form, looks like, just watch, y minus y sub 1 equals m times x minus x sub 1. Do you notice that I no longer have y1 and y2 and x1 and x2? I just have a y1 and x1, which means a single point. This y and this x do not have any subscripts, which means it's just a y and it's just an x, and we're not substitute anything in for either one of those. They will remain x and y. The only thing I'm substituting in is for m, which is the slope, and x1 and y1, which is the point. Are you with me? Now, the other form we had was called point, pardon me. See, that's why I need you doing this stuff with me. The other form we had was known as slope-intercept form. And that looked like y equals mx plus b. Now here's the deal. Some of you are like, well, what's the difference? The titles give it all away. This first title is talking about us getting a point and a slope and plugging it in. Are you with me? This one is talking about a slope and an intercept, as a matter of fact, the y-intercept. This section is all about us finding equations of lines. And if the information they give me is the slope and a y-intercept, I can plug it directly into here, like we did in a previous lecture. If the information they give me is a point and a slope, then I need to use this form. With me? By the way, this form right here, I can use even if the point they give me is the y-intercept. This form works for no matter what point they give me. I just need the point, whatever it is, and a slope. Got it? This one is very particular. This one says if you want to find an equation of a line using this form, you need a slope and a y-intercept. The y-intercept is a very particular point, a very specific point. Are you with me? That's why I like this first one, because this first one doesn't care what the point is. Just give me a point and we're good to go. But now you know where this form came from. It came from us taking the slope formula, multiplying both sides by the denominator, and there it is. Cool? Okay, so I'm going to be back with some examples of finding equations of lines, and this is the form that we are going to be using to help us. All right, so let's look at the directions. Find an equation of a line using the given information. So let's look at the first example. They gave me m, which is the slope, m equals 3. And they're telling me to find an equation of a line. So the information that's given is that the slope is 3, and the line is going through the point 1, 2. With me? Okay, so they gave me a slope, and they gave me a point, didn't they? So which form should I use to help me find the equation? Should I use the slope intercept, or should I use the point slope? Yeah, we're going to use the point slope form because they gave me a point and they gave me a slope. So, first things first, write the generic form down. The generic form is y minus y1 equals m times the quantity x minus x1. With me? If there's a formula, so to speak, that goes with the problem I'm working on, I'm going to write that formula down so I can see where things need to go. So, remember, this y and this x do not have any subscripts. So those are just going to remain a y and an x. Got it? Okay, so let's start filling in the pieces to the puzzle. I have y minus y1, well that would be 2, equals m, well my m is 3, times the quantity of x minus x1. Well that's that number 1. Good? Okay. And now let's go simplify this thing. Y minus 2 equals 3x minus 3. And if they want the equation written in slope-intercept, that means I need to get the y by itself. So you have to add 2 to both sides, which will give me y equals 3x minus 1. Cool? Awesome. Let's look at this one. They want me to find an equation of a line that has a slope of 2/3 and it's passing through the point -9, 4. So, which form are you going to use? The slope-intercept, which was the first one we learned, or point-slope? Good, point-slope, because they gave me a point and they gave me a slope. So, same thing. Let's get the generic form written down so that I can see where the pieces of my puzzle are supposed to go. Cool? Okay, so y minus, good, 4, equals, excellent, 2/3, because that's m, times the quantity. And you're like, what does that mean, times the quantity? Quantity means parentheses. So times the quantity, x minus a -9. Okay, so that double negative is actually, good, a positive, or an addition problem, I should say. So I have y minus 4 equals 2/3 x. Yeah, you have to do 2/3 times 9. So some of you may want to do the work off to the side. So you have 2/3 times 9 over 1, right? And there's a couple of different ways that you can figure that out. But one way or another, you're going to get 6. Because you get 18 over 3. And that's going to be a positive 6. And if they want the answer written in slope-intercept form, you got to get the y by itself. So y equals 2/3 x plus 10. Awesome. Does this make sense? Cool. Hang in there. Got a couple more problems for us. Okay, so let's look at problem number 3. They still want me to find an equation of a line. In this case, problem number 3 is very specific. They want me to find an equation of a vertical line. Now, let's stop a second. Vertical lines. Vertical lines go which way? Yeah, they go up and down, don't they? So here's the thing. Let me just kind of draw us. There's our Cartesian system, right? Our x, y axes. Agreed? And a vertical line goes which direction again? Good. A vertical line goes up and down. And I'm just going to dot it so it's easier to see. So if I draw a vertical line there or even on this side, vertical lines only pass through which axis? Yeah, they only cut through the x-axis. Got it? Just the x-axis. So in this case, am I going to find the variable y in the answer? No, I'm not, because the line's only cutting through the x-axis. It's not passing through the y-axis whatsoever, which means in this particular case, if they want a vertical line, that means it's going to be an x equals line. Are you with me? So look at part A. They want a vertical line passing through this point 2, 6, which means vertical means, yeah, x equals. And in A, x doesn't have a choice. X has to be equal to what? 2. And I know some of you are going, is that it? Is x equal to a vertical line? Sure is. And it will pass through the point 2, 6, won't it? If x is 2 and I go up 6, it would pass right through it, wouldn't it? Yep, that's it. These are one of the easiest problems I could actually give you to work on. Look at part B. Still want a vertical line, and now it's passing through this point. Vertical lines go which direction? Good, up and down, which means they only cut through the x-axis, which means in this case, x equals -4. Awesome. Does that make sense? Cool. You know, I'm going to throw a part C at you. And I know this may sound kind of funny, but part C for problem number 3. I have an undefined slope. And it's passing through the point 2, -4. What does it mean to have an undefined slope? Yeah, you're trying to drive up the side of a building. So if they say an undefined slope, that means you actually have what kind of line if you're trying to drive up the side of a building? Yeah, that means you got a vertical line. And vertical lines start with what variable? Yep, x. So for this letter C, x would have to equal 2. You with me? Vertical lines have an undefined slope. So if they say, hey, find me an equation with an undefined slope, that means you got a vertical line. Cool? Okay. Let's look at number 4 over here. Now number 4 is talking about horizontal lines, isn't it? Horizontal lines go which way? Yep. And they're cutting through which axis? Yeah, they only pass through the y-axis. They only cut through the y-axis. Which means in this case, yep, y equals. And in this case, for letter A, y would have to be equal to what? 1. Good. What about letter B? Yep, y equals 0. Got it? Cool. These are some of the easiest problems I can give you, including part C for problem number 3. Because if you recognize you have an undefined slope, then you know it's a vertical line. Good? Stay tuned, got some more problems for us. Let's look at problem number 5. They'd like me to write an equation of a line, and now they've given me 2 points. Okay, you know, I got 2 forms. I got the slope-intercept form, and I got the point-slope form. Both of those forms require that I know the what? that I know the slope. Did they give me the slope? Nope. So what's the first thing I gotta do? Go find the slope. Okay, so first things first, find slope. First, find slope. So we need to remember m equals the difference of the y's. So 5 minus 13 over -2 minus -6. Now you may have flipped the y's and the x's, but we're going to get the same thing, aren't we? So m equals -8 over, this becomes an addition problem, doesn't it? 4. So I have m equaling -2. Did you get the same thing? Awesome. And now, I have my slope. And now I need a point. Do you think it matters which point I choose? It shouldn't, right? Because both points are supposed to lie on the same line. So, just watch a second. I'm going to take the slope -2 and I'm going to use the point -2,5 with it. Good? All right. So now watch. Now that I've got a point, now that I've got a point and a slope, I'm going to use the point slope form, which means we're going to write down the generic form to make sure we've got that down and know where the pieces to our puzzle are supposed to go, right? So y minus, good, 5 equals, excellent, the -2 because that's the slope, times the quantity x minus, right, a -2 because that x is negative. Which means in this parentheses becomes an addition problem, agreed? Okay, so we have y minus 5 equaling -2x minus 4, and I want it in slope intercept, which means the y has got to be by itself, and then I end up with -2x plus 1. Cool? Okay, now, because I know some of you are thinking about it, you're like, but what happens, I'm going to use the slope -2 because that's the only slope I've got. What happens if I chose the point -613 instead? Would I get the same thing? Let's go check it out. So again, write your generic form so that you know where to plug in the pieces to your puzzle. Got it? So in this case, we have y minus 13 equaling -2 for the slope times the quantity x minus a -6. This double negative makes it an addition problem. So we have y minus 13 equaling -2x minus 12. And then you've got to add the 13 over if you put it in slope intercept, right? And I'm going to write it over here because I'm running out of board space. So when you add the 13 to both sides, you end up with y equaling -2x plus 1. This is such good news because these two equations are exactly the same, and it didn't matter which point I used because I got the exact same equations. Cool? Okay, so when all they give you is 2 points, you're going to have to go find the slope. Once you find the slope, it becomes like the last, like the first 2 problems we worked on, right? And clearly, we showed it doesn't matter which point you choose to go with that slope because you're going to get the same answer. So, whichever point you think is easier to use, whichever one floats your boat, so to speak. Got it? I'll be right back with some more examples, so hang in there. Okay, so let's look at problem number 6. Still looking for an equation of a line, but now it's parallel to y equals 4x minus 2. And it's passing through the point 3, 8. So, let's refresh our brains. If the line is parallel to y equals 4x minus 2, then what do you know about the new line? Yeah, parallel lines have the same slope, don't they? So here's the deal. In the equation for y equals 4x minus 2, the slope is equal to 4, isn't it? Well, my parallel line slope must be m equals 4. Because parallel lines have the exact same slope. Are you with me? So I got the slope, right? For the new line, right? The new line, I know that the slope is 4. Make sense? Because it's parallel to y equals 4x minus 2, so they got the same slope, don't they? Good. But I also need a point. Yes, it's passing through this point 3, 8. So I have a slope now, and now I have a point. Well, they gave me the point. I needed to find the slope, didn't I? Okay, so what are we going to do? Yeah, let's get that generic equation written. The y minus y sub 1 equals m times the quantity x minus x sub 1. So I know how to fill in all the blanks, fill in the puzzle pieces. So we get y minus 8 equals 3 times the quantity, x minus, whoops. See, this is why I need you guys doing it with me. The slope isn't 3. What did we say the slope was? Yep, the slope is 4. So good catch, you guys. I heard you. You're like, wait. Good. So check again. Y minus y, which is 8, equals m, which is 4, times the quantity of x minus x, which is 3. Good? Cool. Okay, you guys know where to go from here. You do your work while I do my work, and hopefully we end up with the same answer. And unless they say otherwise, we're always going to write the answer in slope-intercept form. Cool? Lovely. Okay, let's go to problem number 7. They want another parallel line, and in this case, it's parallel to 3x plus 2y equals 5. And it's passing through the point -2, -3. Well, if it's parallel to this one, that means they have the same slope. And yeah, in this case, the slope is not obvious, is it? So, first, solve for y. Because to find the correct slope, I need the y by itself, don't I? Good. So when I do this, I get y equals 5 over 2 minus 3 halves x. Did you follow? Do you agree? Good. So in this particular case, m is equal to -3 over 2. Correct. Which means the parallel line's slope is m equals -3 halves. Make sense? Because they have to have the same slope. Problem number 7 made me do a little more work, didn't it? It made me go find the slope. It made me get the y by itself, didn't it? That's okay. We can handle it. All right. Now, let's get that generic equation written down. Y minus y sub 1 equals m times the quantity x minus x sub 1. And, oh, wait a minute. What's the point we're using? Yeah, the point we're using is -2 and -3. Good. Okay. Good idea to write that down too, yes? All right, so let's go fill in the puzzle. So we have y minus y sub 1, which is -3, equals -3 over 2 for the slope, times the quantity x minus -2. Cool? Okay, so this subtraction problem is actually an addition problem, so is that one, right? Okay, so we have y plus 3 equals -3 over 2x. Yeah, that's minus. And now you got to do 3 over 2 times 2 over 1. Go ahead, I'll wait. Good, you get -3 because the 2's drop out, don't they? And then you got to minus this 3 from both sides. So y equals -3 over 2x minus 6. Good. Here is the line parallel to this one. And this answer, here is the line parallel to that one. Good? Hang in there. Got a couple more examples. Let's look at problem number 8. Now they're asking us to find a line perpendicular to this one, passing through the point -4, 8. So what do I know about lines that are perpendicular to each other? Something about their slopes. Good. When they're parallel, the slopes are exactly the same, right? But what about when they're perpendicular? Good. There's 2 requirements. One slope is positive, the other one is negative, and they're reciprocals of each other, right? They're flip-flops of each other, right? Okay, so I guess I got to go find the slope first, don't I? Because they gave me 2x minus 3y equals 1 as the equation. So, first, find slope. And they gave me the equation 2x minus 3y equaling 1. Agreed? So to find the correct slope, get the y by itself. So we have -3y equals 1 minus 2x. And then what? Good, divide everything by -3. So I have y equals -1/3. And negative divided by negative is positive 2/3 x. Correct? Okay, so the slope here is 2/3, right? But I need the perpendicular slope because they said perpendicular. So the perpendicular line's slope would be m equaling, good, since this one is positive, this one's got to be negative, and it's got to be the reciprocal, right? It's got to be the flip of it. So if this is 2/3, then it is 3/2. Cool? Good. Okay, now look at the information you have. So the new line, my information is the slope equaling -3/2, and the point is -4, 8, right? Okay, so let's get our generic form down, because now it becomes like the last few problems we've worked on, right? This part is all the same. I have to make sure and plug the puzzle pieces in correctly in order to get the correct answer, don't I? Okay, so I know you guys are getting the same thing I am. So let's see. That'll be negative, won't it? -6 is what I got. Did you get -6? Good. And then add the 8 over, so we get -3/2x plus 2. So what you're telling me then is, here is the line that is perpendicular to this one. And also this one, because this is the rearrangement of it, isn't it? And if you notice, right, this one's negative, this one's positive, and they're reciprocals of each other, aren't they? Cool? Okay. Let's look at this number 9 over here. So, on number 9, they would like another perpendicular line, and it's got to be perpendicular to y equals 7 and passing through this -5, 0. And you're like, wait a minute, I don't see an x. Neither do I. Problem number 9 is actually quite easy. So just listen, don't write, just listen. Y equals 7 is what kind of line? Good, it's a horizontal line. So let me just draw this, okay? Y equals 7 is a horizontal line. It's passing through the y-axis only, because there's only a y in there. It's passing through the y-axis through the number 7, right? This is y equals 7. Agreed? All right, so now I need you to think about this. A line that's perpendicular to a horizontal line looks like what? I need the other line to meet this at a 90-degree angle. So if the current line is horizontal, the other one's got to be vertical. Yes, right. This one, the new line has got to be a vertical line. Now, mind you, it's passing through the point -5, 0, correct? Okay, so let me go find -5, 0. So there's the point -5, 0. So my vertical line's got to pass through this. And there it is, correct? Because that's the 90-degree angle, isn't it? Yeah, vertical and horizontal lines are the only ones you can actually graph this and say that they're 90-degree angle intersection. Okay, so that means this new line is an x equal line, and x must equal -5. Got it? Number 9 is actually a very simple problem. You just got to think, oh, if it's a horizontal, the vertical is perpendicular, right? Cool. Hang in there. Got a story for us. All right, so let's look at the story. A rock is dropped from the top of a 400-foot building. After 1 second, the rock is traveling at 32 feet per second. After 3 seconds, the rock is traveling at 96 feet per second. Okay, got an idea of what's going on. Top of a 400-foot building, dropped a rock. After 1 second, it travels at 32 feet per second. After 3 seconds, 96 feet per second. Cool? Okay, so part A. Write a linear equation where y is the rate of descent and x is the number of seconds since the rock was dropped. Okay, if they want an equation, right, a linear equation, I need a slope and I need either y-intercept or a point, correct? Okay, but it's the easiest way to go is to get a slope for sure and just a point, right? I'm never guaranteed a y-intercept, but I'm guaranteed at least a point. All right, so let's look at the information they gave us. So they say x, right? And x is the number of seconds, and y is the rate. Okay, so let's look. We got a rock drop from the top of a 400-foot building. It's fluff. It makes the story sound good. After 1 second, what's the 1 second represent? Yeah, that's an x, isn't it? So I already got an x of 1 second. The rock is traveling at 32 feet per second. Yeah, that 32, that's the rate of descent, isn't it? So it goes with the 1 second, doesn't it? So there's a point, 1 comma 32. After 3 seconds, there's another x, isn't it? The rock is traveling at 96 feet per second. There's another rate. So, looky there. I actually have 2 points, don't I? Okay. Am I going to be able to find the linear equation? I sure am. This looks like problems, what, 5 and 6 I think we did? All right, so first things first, what do you need? You need the slope. So first, find slope. Okay, so m equals, I'm going to do 96 minus 32, divided by 3 minus 1. So that looks like, good, 64 over 2, which is 32. Got the slope. So now I also know that m equals 32. Does that make sense? All right. Am I ready to write that equation? I'm ready to plug it in at least, right? And we have to plug it, this is second, and we have to plug it into this particular point slope form. So I'm going to use this point. Why? The numbers are smaller, that's all. So y minus 32 equals 32 is the slope times x minus 1. So I get y equals y minus 32 equals 32x minus 32. Add that 32 to the other side, right? Wow, this looks like y just equals 32x. Because those 32's dropped out when I added it to the other side, didn't they? Right? When I added 32 to both sides, they dropped out, didn't they? Well, so be it. If they drop out, they drop out. Good enough. Did I find the equation? I sure did. Y equals 32x. That's it. Now there's a part B. Part B says, well, what's the rate of travel after 4 seconds? Well, I have the equation, don't I? 4 seconds is time, isn't it? And isn't that the x? So what do you think you're going to do? Good, plug it in. So I'm going to have y equals 32 times 4, which means y equals, I know you guys got your calculators out. Good, 128. What's the units? 128 what? Yep, feet per second. Does this make sense? As always, stop the video, go back and rewind it to whatever part you need to make sure you understand what we were doing here, especially with this story. This story isn't that bad in actuality. They hid the 2 points in the story. Once I found the 2 points, then I found the slope, and then I took the slope and one of the points and plugged it in and found the equation, right? Cool. Okay, you guys have fun with this stuff, and I'll catch you on the flip side.